Let's see, team. So what I am telling here is, team, let's see, team. So I am having a source this. So this is one source. Okay. This source is this, and this is the destination. I am talking in a simple way. Okay. So this is here there are two roads here. This is the one road and this is the one road. And this roads generally, let's see, forget about this. I'm having a single road from here. Source, this is some village and this is some village. So to travel from this village to this village, this is the path having. Now, this path in the middle, there is some river flowing. So on the top, so to cross this river, they given a small footover bridge. So this is a footover bridge. So if I cross this footover bridge, then again the road. So I'm going and connecting to the. I'm going and I will go to the destination. So now let's assume here. So daily I am going through this way and I am reaching the destination. So what would be the chances of failure of this? Maybe that road damaged, purely damaged. You are not passing through this. Or maybe due to the damage of this footover bridge. Maybe due to the footover bridge. Now, I am talking this two with an letters of A and B. A is and B is one more equipment or some component which are used, which are very helpful to send the source to the destination, to send the person from the source to the destination. So A and B are the two components here. If these two components works well, then only a person will go from the source to the destination, or the power will reach from source to the destination. So now they have done the reliability analysis. So I am asking that manufacturer A, manufacturer A, what is the reliability of your component? Then the manufacturer A said that the reliability of my system is 0.99, which is 99% I am reliable. It seems that 1% is a failure of this component. And I went to the B and he said that my reliability is only 0.985. 98.5% only, I can say that I won't fail. There might be 1.5 times of failure of the B component. So then a question was raised by one of the person there. Then what would be the reliability of this entire path? He is saying he will fail weekly once. He is saying he will fail 1.5 times in a week. Then what is the reliability of the entire system? We have to multiply this to 0.99 into 0.985, which gives you the number of 97.5%. Check, see here. 97.5% is not the reliability of the B as well as the reliability of the A. The reliability of the A and B are much greater than the resultant one. Why this was dropped? There might be a chance that Monday A failed and Tuesday B failed. So in a week, both 2 times the failures are there. So it results to the failure of 2.5%. Just multiplying this. So the failure of this path, the failure of this component is 99 only. only 1%. And the failure of component is 1.5 only. But what is the failure of the entire the system or entire the path? It is 2 times, 2.5 times. Because today it failed, tomorrow it failed. Similarly, so the reliability of the system depends upon the reliability of the equipment associated in that system. The reliability of the entire system depends upon the reliability of the equipments associated in that system. If you are purchasing a low quality component in the middle of the substation, due to that, the reliability of the entire substation comes down. So what is the probability of failure of the system? 2.5% is the probability of failure of the system. So if I want to make down this, then what I have to do? I have to lay one more path for this from source to the destination. One is AB, and I will add one more AB path. As a reliability, if this path failed, this would be there. Then here also, what is the probability? What is the failure rate now? So 0.99 is the reliability of this component and this component. And the reliability of the B component is 985. Then what is the reliability of this entire system with the 2 paths? Then the answer for is, so what is this, the failure now? 1 minus 0.9753 for the first path. I am talking about this first one. 9753 I got by multiplying these two. I am calculating the failure rate, which is 0.0247 is the failure rate of this one. And the failure rate of this one also 0.0247. I am multiplying the failure rates of both. So now it gives me the resultant of 0.0006. This is the failure of the 2 systems. Then what is the reliability? 1 minus failure, which is 0.0006, gives me 99.94%. If I add A and B, additional A and B, my reliability increased from 97.5 to 99.4. How much percent it increased? 2.4% increased, team. 2.4% increased reliability. Reliability 2.4% increased. It seems that in a span of, suppose in a year, I am reducing 2 failures. I am reducing 2 failures. Let's example. I am reducing 2 failures in a year by adding these 2 components. Let's suppose for a failure, I am losing 1 crore rupees due to the repair cost or shutdown, anything 1 crore rupees. So every year, I am losing 2 crore rupees every year. So now I am calculating what is the cost of placing a additional AB with respect to this. I am adding one more AB, right? So what is the additional cost of this AB? Suppose the additional cost of this AB is 10 crores, capital cost. But I am saving 2 crores per annum. So the 10 crores I can get in the next 6 hours or 7 years if you add interest, depreciation, everything. My project cycle is 15 years, 20 years. I am getting my money back in 6 years. So addition of one more A and B is quite good for my project. So how much you are losing? 1 crore for the failure. So this depends upon what? Repair cost. Repair cost, it won't be in your hands. It will depend upon the equipment. CT will cost 5,000 rupees. Transformer will cost 5 lakh rupees. LA will cost some thousands rupees. So you can't see. So there is some equipment, so there is some factor which is influencing it more and more. What is that? That is my power generation. When the system is failed, I am not able to send the power from my substation to the grid. I am losing some power, which is again the indirect one, which is the tariff. If my tariff is good, if my tariff is high, see for solar and wind plants, if my tariff is very, very high, 6 rupees, 7 rupees, it could be 1 crore rupees here. So I require much reliable system. If my tariff rate is very, very low, 2 rupees, 1 rupee. So if a failure, it won't be 1 crore, it will be comes to 20 lakhs or 10 lakhs. So if it comes to 20 lakhs, 40 lakhs, so to get 10 crores, how many years you have to wait? Nearly you have to wait 5 to 6, 30 years. So it won't be applicable for our project. Only a single is the best for my project if my tariff is 2 rupees. Double line is required for my project if my tariff is 6 rupees or 7 rupees. I'm just example telling. So it totally depends upon the main factor is tariff. Sounds good? Clear, team?
Okay, sir.
Yeah.
So,
Any doubts?
by tariff, we will decide the electrical system plan, right?
Yes. Not only tariff, it's again depends upon the in substations.
Reliability.
Yes, in substations, main factor is tariff. And if you go for the industries, there it depends upon the outage, plant outage, production outage. Suppose in auxiliary supply lost, so the cylinders are not manufactured. There is some delay, so you are losing some amount. Got my point?
Yes, sir.
Yes, that you have to calculate. In the substations, we are calculating the respect to the tariff. Clear, team? Understood?
So in industries also the reliability plays a major
very,
factor.
very important. In the substations, it's not mandatory, it's not required, but in the industries, it is very, very required. Because if you just recall the industry and the substation, if you keep side by side, then you can see where you can find the most auxiliary supply distribution. Obviously, industries. We are having plenty of motors, stepper motors, induction motors, squirrel cage motors, machines will be there, compressors will be there, pumps will be there. All these things will be there. So there is a much high weightage for the reliability analysis. In the substations, not much. So generally, the substations, we won't do all these things. Generally, suppose for as a practice, they will go with 2 transformers or 3 transformers like that. But as an electrical design engineer, we have to provide the justification for every aspect of design. So we should know this. Make sense?
Makes sense, sir. Thank you.
Yeah, thank you. So this is a general brief overview of the reliability analysis. So if you have any doubts, you can ask. If all fine, I will move to the practical approach of this. So we are calculating the general, simple I'm saying, we are calculating the failure rates and associated repair time. And then we are calculating the what is the capital cost of the equipment if I place 2 number of lines. And I will check, I will correlate with the failure, outages, everything. And I will come with a good solution. So this process we will, in IEEE 485, this we will call as a minimum revenue requirement method, MRR method. I will explain that in a while. So if you are all fine with this, I will go to the next. Clear, team? Shall I move? Cool. Yeah. So here I am considering an example team. This is the example for our analysis now. This is a simple example I am considering for because in the substations, as I said, we are not doing this. So I considered an industry example here. So we will do the reliability analysis on this case. Let's see that. Fine.